The topic I am going to discuss is about non-ionizing radiation. Non-ionizing radiation, it refers to any type of electromagnetic radiation that does not carry enough energy per quantums to ionize atoms or molecules, that is, to completely remove an electron from an atom or molecule. Non-ionizing radiation. NIR. Non-ionizing radiation, it refers to radiative energy that instead of producing charged ions when passing through matter, it has sufficient energy only for excitation. The NIR spectrum is divided into two main regions, optical radiations and electromagnetic fields. The optical can be further subdivided into ultraviolet, visible and infrared rays. The electromagnetic fields are further divided into radio frequency, which is microwave, very high frequency and very low radio wave. Non-ionizing radiation, it originates from various sources. It first is natural origin such as sunlight or electrical discharges, etc., and man-made, which is seen in wireless communication, industries, scientific and medical applications. What is the non-ionizing radiation? Non-ionizing radiation is the radiation that does not ionize an atom. In this electromagnetic spectrum, we can see it starts from radio waves to microwaves, infrared, visible, ultraviolet. All these comes under non-ionizing radiation, and for ionizing radiation, it is X-rays, gamma rays, and cosmic rays. Non-ionizing radiation has low frequency, whereas for ionizing radiation has high frequency. However, wavelength is low for ionizing radiation, and for non-ionizing, wavelength is large. There are two types: optical radiation, which is divided into ultraviolet, infrared, and visible rays, and radio frequency radiation, which is microwaves, radio frequency, extremely low frequency. These are the two types of non-ionizing radiation. Radio frequency, RF heating. It is an advanced and emerging technology for food application. Radio frequency RF is known as high frequency dielectric heating, as it refers to the heating of dielectric material water with electromagnetic energy at frequency between 1 to 300 megahertz. It has high penetration power than microwave. The prime goal of this novel technology is food preservation by ensuring its safety and quality. History of radio frequency heating. It was first used in 1895 as a medical treatment method. In food processing, it was first explored for blanching and then for cooking and dehydrating. In 1960s, many attempts were made to use radio frequency to thaw frozen foods. In those studies, different frozen food materials were tested using lab scale and even industrial scale, that is 25 kilowatt RF systems. Principle of radio frequency heating. Molecular reorientation and friction occurs due to continuous realignment, that is action of changing different position or state of the molecules. Ionic movement towards oppositely charged electrode. Due to this rapid change in polarity, it causes generation of heat. As you can see in the diagram, there will be no orientation among the molecules, because by applying radio frequency, the molecules will reorient according to themselves, and friction will occur due to this reorientation. Because of this friction, there will be a rapid change in polarity which causes generation of heat. That is the principle of radio frequency heating. In this figure, you can see the space change and dipolar polarization in an alternating electric field at radio frequencies. Radio frequencies heating mechanism. Here you can see the diagram of that radio frequency, where food is kept between two electrodes and voltage is supplied and capacitor is used for storing electric charges. In radio frequency heating, the food is placed between two capacitor plates or electrodes. In this, it plays the role of a dielectric where high frequency alternating electric field is applied. The electromagnetic energy transfers directly into the product, therefore, it induces volumetric heating due to frictional interaction between molecules. Such field will force polar molecules, that is water, to constantly realign or reconstruct themselves within the electric field. This molecular movement is very fast due to the high frequency of the field. It will cause the generation of heat within the food by energy dissipation caused by molecular friction. Here is the diagram of the general radio frequency heating process. In this, the radio frequency wavelengths, it covers the range of electromagnetic spectrum from 3 kHz to 300 MHz. Only frequencies of 13.56 MHz, 27.12 MHz and 40.68 MHz are permitted for use in the United States. Radio frequency versus conventional heating. In conventional heating, there is conduction convection radiation. The heat source on the outside, heat is transferred from the surface of the material and then conduct the heat to the middle of the material. In radio frequency, it is different. In this, it heats at the molecular level so that heat is produced within the material and heats the middle as well as the surface. It is uh, opposite to each other. Advantages of using RF in food processing. In radio frequency heating and drying benefits over conventional heating and drying methods. It produces faster heating and reduces drying times. It has more uniform heating and drying. It has high efficiency. It has selective heating. It has high energy efficiency. It produces contactless heating. It produces deep penetration heating. It avoids overheating on the surface of the product. Disadvantages. Disadvantages of using radio frequency in food processing. Equipment and operating cost. In RF heating, equipment is more expensive and operating cost is higher than convention, radiation or steam heating system. It is also more expensive than an equivalent ohmic heating system. Factors influencing RF heating. Dielectric properties, permittivity and permeability. Permeability, it is the free space and not assumed to contribute to heating. Permittivity, it is reported in terms of dielectric constant E and loss factor E dash, which influence the heat rates. E equals E dash minus J E double dash. It is also influenced by moisture content, frequency of applied alternating field, temperature and chemical composition of the material. Another physical factors that affect RF heating systems are shape of the product, geometry and product proportion. These are the applications of RF heating in food industry. It is used for pasteurization, blanching, thawing, meat processing, sterilization, heating of bread, baking and drying. And these are the previous successfully applied applications of RF heating for food industries. For thawing of frozen food, for example, fish, meat and egg, the frequencies ranges from 14 to 17, 36 to 40, and it is taken from the reference Jason and Sanders 1962. As for tempering, post baking, for everything, for each food item is used. For example, for roasting, cocoa beans is used, which is the frequency of 60 MHz, which is used in electro-technology application system PA. These are the various previously successful application of heating in food processing. Thank you. Next class we will go see about microwave heating and its uses. Thank you.